what we're going to do today is I'm just going to go over examples of how to find the area and perimeter of the basic shapes. The 5 basic shapes that we covered, you should have done your flip grid on. I got 2 of you guys flip grids on Monday. The area formulas for the 5 basic shapes are right here. The area of a triangle is 1/2 base times the height, right there. The rest of this is just telling you how to say the variables. The area of a rectangle is length times width. The area of a trapezoid is 1/2 base 1 plus base 2 times the height. The area of a parallelogram is base times height. And the area of a circle is pi r squared. I'll get into what the circumference means shortly. But basically I'm going to go over each one of these shapes right now. Starting with the warm-up, I'm going to get right into the other shapes. We're going to take notes on that, then you'll practice on your own on C46. So in other words, C46 is right here. So today's a special day. We're actually finishing credit 4. It's kind of crazy. C46 is right here, Thursday. Notice C46 and 47 are Thursday today. You're going to take notes on Zoom. Obviously, you're doing that now. And you're going to do the area and perimeter practice problems. Just do it on Cami. Let me make sure everyone's got a copy of that. Yep, everyone's got a copy. And yeah, open that up. Use Cami, add some pages at the bottom. Show me your work. There's only, let's see. There's only 8 problems. Okay? Remember, if you only want to get a 1 on this, just do 2 problems correctly and you get a 1. If you want to get a 2, just do 4 problems correctly and you get a 2. Right? You don't have to do all the assignment if you just want to get credit and move on to your next assignment. That's something for those of you who are not really shooting for an A, always keep that in mind. If you just get 20% right on any assignment I give you, you get at least a 1. Then today, later on today, the last half hour of class, we're going to take the weekly quiz. The weekly quiz will have perimeter and area problems on it, so you want to take the first hour seriously and practice and take it seriously, okay? So this will just be an area and perimeter quiz, what we covered on Monday and what we're covering today. That'll be towards the end of class. I'll leave that quiz on even after class ends. And if you want to take it later at 12:30 today during my tutoring hours, you can come and take it then too. It's up to you. So if C47, we're going to end credit 4 with a quiz. When we see each other again on Monday, we'll already be starting credit 5, the last and final credit. That's kind of crazy. We're moving. In other words, after today, we're going to meet 6 more times, and we're done with the year. After today, we meet 6 more times. That's going to move quick. So be prepared. Let's do this. Let's find the area of a triangle. Okay? I'm going to use this formula. Area equals 1/2 base times height. Let me write it down right here. Area equals 1/2 the base times the height. Now, for our formulas, notice the shapes that have a height. When I'm looking at the formulas for a triangle and a trapezoid and a parallelogram, those 3 shapes out of the 5 have a height in it. Look at, I'm going to underline in red, height. Height, height. Rectangle doesn't have height, neither does a circle. Only the triangle, trapezoid, and parallelogram have height in it. I want you to pay close attention to what height is. Okay, here we go. When I look for the height of a triangle, a parallelogram, or a trapezoid, what I'm looking for is, ready, watch this now, because there's a lot of confusion about this. I'm looking for the perpendicular distance. So I'm going to write it right here. The height is the perpendicular distance. Now, when I write perpendicular, you're probably like, what the heck is Munguia talking about perpendicular? What does perpendicular mean? That's probably what you're asking. Does anybody know what perpendicular means? Ramos, Barragan, Morales, or Catarino here in my classroom? Does anybody remember what perpendicular means?
Like the same.
Nice. I like that. That's congruent. I like that. I like how you're thinking. Congruent means the same measure. Perpendicular means something else, though. I'll give you a free assignment pass if someone can tell me. Perpendicular.
I don't know exactly like the opposite. Like I don't know.
That's fine. I like your contributions. Thank you for trying.
Isn't it like when it's crossing?
More specific, that's just intersection. It crosses at a special. Give me more. 5 more seconds. 5, 4. Go ahead.
Distance.
Close. 3, 2. Here's what perpendicular means. Look at this triangle over here. Yikes. Okay. Okay, watch. Let me put a new one here. So perpendicular means, okay. What I want you to do is keep your eye on this angle right here when I manipulate it. So when I take this triangle, and here we go. Not letting me manipulate it anymore. Hold up. Watch this. Mr. Mungia needs practice with this thing. Hold up. All right, watch this. So look at this angle at the bottom right. Notice I'm going to make it bigger. Okay. Notice it's 75 degrees, 76. What I want to do, actually what I'm going to do, focus on the top angle. The one that's 83 degrees. Look at the top angle there. Notice I'm making it bigger. Now I'm making it smaller. Again, focus on the top angle. Now it's 62 degrees, 57. Perpendicular means this. Watch. I'm going to make it exactly 90 degrees. Okay? So this angle was 90 degrees. And the universal symbol is a little box. That's what perpendicular means, is when two lines intersect at 90 degrees. So coming back over here at this triangle, I'm looking for perpendicular. And I see it right here. Watch. I see it right there. So that tells me that this is the height of the triangle. And this right here is the base. So the base and the height, no matter if we're dealing with a triangle, a trapezoid, or a parallelogram, the base and the height always meet at 90 degrees. That's the moral of the story of what I'm trying to get at right now. So when I look at this triangle, the height is going to be this dotted line. And it's actually, notice how the height is really not even a side of the triangle. It's kind of inside. But because it's perpendicular, that is 90 degrees, with this bottom side, this is the height then. And I forgot to actually give you the height. Let's make this 6 centimeters. Okay. So, all that to say, base and the height always meet at 90 degrees. They always are perpendicular. They're always 90 degrees. They intersect at 90 degrees. So Morales, when you said intersecting, you're on the right track, but they intersect at 90 degrees, exactly a right angle. That's the gist. Okay, hold up. Okay, so let's do it. We're ready to rock and roll. My height is gonna be 6. My base is 10. Let's go ahead and plug and chug into our formula. Remember, a formula is kind of like a recipe. If you want the area of something, just plug and chug. 1/2 here, the base here, the height here, and you're rocking and rolling. Here we go. 1/2, the base is going to be 10, the height is going to be 6. So 1/2 times 10, so look, I'm just multiplying 3 numbers now. 1/2 times 10 is the same as 10 divided by 2. 1/2 times 10 is the same as 10 over 1, so it's going to be 10 divided by 2, which is 5. So 5 times 6 is going to be 30. So the area then, watch this now. Remember, area is two-dimensional space inside. We went over that on Monday. The space inside this triangle, right? We're dealing with the inside, the area. So what we're dealing with then is square centimeters. This is, the area is 30 square centimeters. All right? Remember, the squares that fit inside the shape is what area means. Now, what is a square centimeter? That would be a square. Think of a square where every side's 1 centimeter. What we're saying is, look at 30 of these would fit inside this triangle perfectly. It would fill it up. The inside, 30 squares, 30 square centimeters. Okay, that's what area means. So every time you're dealing with area, you have to have square centimeters, square inches, square units. It's got to be square something because we're dealing with square tiles here for area. Let's find the perimeter. I'll put the perimeter in dotted blue. So the perimeter of this triangle, remember the perimeter? When we deal with the perimeter, remember I asked you to always think of that stick man that was walking around that pentagon from that video I showed you? So someone's going to walk the boundary of the triangle, that's the perimeter. That is just someone walking all around the triangle perfectly. That's what perimeter means. So it's going to be, he's going to walk 7 centimeters plus another 7 centimeters plus a 10 centimeters. So that's going to be what, 24, huh? 24 centimeters. Notice it's not square centimeters, it's normal centimeters. How far did this guy walk? Well, 7 plus 7 plus 10. Okay? Linear, we're talking about linear units. 1 dimension. So pure distance is 1 dimension. I went over I think I showed my measuring tape. So those of you in Zoom land, I got a measuring tape here. The distance between you and the camera, notice me, that's only 1 dimension, the distance between any two objects. It's just pure distance. Pure distance. Okay? That's just a one dimension. But once I get into flat surfaces, we're dealing now with length and width. That's what we got with a triangle. It's 2 dimensions. It's a flat surface. That's why area, the area had to be square units, but the perimeter is just normal centimeters. It's just linear, 1 dimension distance. It's just how many centimeters is around the triangle. Let's get into example 2. Here we go. Let's try a parallelogram. Okay. Parallelogram. Welcome. I think Garcia's almost here. Garcia, welcome. To get some paper out, we're taking notes. We're on example 2. Oops. And here we go. All right, so here's example 2. Let's find area and perimeter. I'm just put A and P, okay? Just to save me getting a hand cramp. go ahead and copy that down. So we got a trapezoid. Here we go. What's a trapezoid formula? Let me go to my formulas. Remember, I put this formula table on C45. So I'm dealing with trapezoid now. So trapezoid's right here. The area is, look at 1/2 base 1 plus base 2 times the height. Again, everything after the equal sign is just, this is just to tell you how to say the stuff, how to say the variables in the formula itself. The formula is right here. Formula for parallelograms right here, formula for circles right there. Don't worry about the stuff after, that's just telling you how to say it, how to pronounce it when you look at this table. Again, this is for you. I made a copy for you on C45 from Monday. So, here we go. The trapezoid then, the area is 1/2 base 1, b sub 1 plus b sub 2, I'll get in what the bases are right now, times the height. It's it's the funkiest formula out of the 5 shapes. Okay? Now let me get into what the bases are. The bases are the two sides that are parallel. In other words, this side that's 8 inches, if you're to extend it forever, and the side that's 14 inches, if you're to extend it forever, those sides would be parallel. That means they would never intersect. The lines would go on forever without touching. Those are the bases of the parallelogram, the two sides that are parallel. Okay? So if I took this parallelogram, or this trapezoid rather, I keep saying parallel. If I went like this, the bases are still the sides that are parallel. Okay? It doesn't matter the orientation. Okay? The bases are the two sides that are parallel. So in this case, 14 and 8. Okay? If I'm going too fast, stop me and ask me questions. So 14 and 8 are my bases. And now my height and my base, look at my height. Remember, when I look for a height, think of what we just did on the first example. The height is, look at it in red, I'll go on the right. The height is the perpendicular distance. Same goes with the trapezoid now, look at it. I'm looking for perpendicularity, 90 degrees is right there. That means 10 is the height. I'm ready to rock and roll. I'm ready to plug and chug in my formula now. Here we go. The area then of a trapezoid is 1/2. The two bases are 8 and 14. And the height is 10. Let's do please excuse my dear Aunt Sally. Remember the good old days of junior high? You do what's in parentheses first. So the area then is 1/2. 8 plus 14 I want to say is 22, huh? My coffee is kicked in. This is good coffee, by the way. Let's keep going. Area then is 1/2 times 22. Let me go ahead and multiply. The 1/2 times the 22. That's the same as dividing by 2. In other words, multiplying by 1/2 is the same as dividing by 2. So 22 divided by 2 is going to be 11. 11 times 10 is going to be 110, right? Yeah. 110 what though? Square inches. Because look at everything's measured in inches, right? See? So we're dealing with square inches here, ladies and gents. Square inches. And what's a square inch? It's a square where every side's 1 inch. And what we're saying is, look at 110 of these squares would actually fill up the trapezoid. It would fill it up. Imagine just filling this whole trapezoid up with squares, little squares that are 1 inch. Imagine doing that. What we're saying is 110 of those squares would fill up the trapezoid. Remember, the area is inside. That's what the area means. Let's find the perimeter in red. put P for perimeter. Remember for perimeter, you're thinking of the little stick figure guy from the video on Monday? Remember? He's walking around. I'll draw him up here. Stick figure guy. He's walking around the whole boundary of the trapezoid. How many inches would he walk? Well, 8 plus 12 plus 14 plus 12. Get my calculator. Actually, I have it right here. So let me get my calc. There we go.
I think it's 44.
One more time, go ahead.
I said, I think it's 44.
Should I just trust you, or should I try it on my own? You're pretty trustworthy. He says 46, so 8 plus 12 plus 12 plus
Actually, yeah.
14. 46.
Yeah,
So
yeah, it might be 46, yeah.
So 46 inches is the perimeter. Notice it's not square inches, it's just inches. Not square inches. Square inches has to do with area only, because that's how many squares fill it up. Area is two-dimensional space. Perimeter is one-dimensional, just pure distance, one-dimensional. That's why it's just one-dimensional inches, as opposed to two-dimensional inches. We got to get that straight. That's more important than getting the right answer, is understanding what area means. Okay? Example 3. 2 more quick examples and we're done. Woo! This coffee is good. Let's go. Let's do parallelogram. How about that?
Are we going to be turning in the notes, or are we going to do an assignment?
You're just going to do the assignment, so the notes are not,
Alright.
yeah. Go ahead and draw yourself a parallelogram. Let's say this is 7 miles. Let's say the height is 5 miles. And that's it. Let's just find the area on this one. This is example 3. Find area only. We'll skip perimeter, because perimeter is just adding up all the sides. We're done with perimeter for now. Find the area. So we've got a parallelogram. Why is this a parallelogram? Well, because this side, right here, the 7, and this side, which is 7 also, they're parallel. In other words, if I were to extend them infinitely, imagine if I were to extend the lines, they would be parallel. They would go on forever without intersecting. And not only that, this side too. Look at this side over here, if I were to extend it, and this side, if I were to extend it, those would also be parallel. They'd go on forever without intersecting. That's what makes a parallelogram a parallelogram. In other words, both sides of opposite sides are parallel. So let's find the area of this puppy. The area is one of the easiest ones out of all the 5 shapes. It's base times height. Area is base times height. Parallelogram. Rocking and rolling. Let's do it. Area is base times height. Now notice on this parallelogram, I'm looking for perpendicularity, and I find the perpendicularity outside the parallelogram itself. In other words, there's 90 degrees, but it's not even inside the parallelogram or even part of the parallelogram, it's outside, which is still fine. That means the height then is 5 miles. Look at right here. Notice how the height is not even part of the parallelogram, but it's still perpendicular distance from that and the base. The base is going to be 7 miles. And notice how it technically doesn't even touch the base. It only touches the base if we extend the base out. And then you find this perpendicularity, the 90 degrees right there. outside the parallelogram itself. That happens sometimes, and that's okay. It also happens for triangles. A little side note. Just a little side note. Watch this triangle, watch. And something. If I had a triangle like this, watch. Imagine a triangle that looks like and I had a height like this. There's a 90 degrees right there. The 90 degree, the perpendicularity would be outside the triangle. All that to say is that sometimes the perpendicularity, the perpendicular aspect, is sometimes outside the shape. It's like what we have right here on the parallelogram. So the base is going to be 7. The height is going to be 5 miles, and the height is actually outside the parallelogram. So keep that in mind. Sometimes the height will be outside the shape itself and actually not even part of the shape. So the area then is going to be 7 times 5. Wow. Is that it, Mungia? Yep. The area then is going to be 35 what? 35 chickens, 35 horses. What are we counting here? Anybody?
Square miles?
Square miles, right?
Yeah.
And Ramos, what is a square mile? If someone asks you what's a square mile, what would you say?
It's like a cube with mile, like, or no, the square with the mile for each
Exactly.
side.
It'd be a square, a perfect square, where every side's 1 mile. That's a big square. Think about it. So what would we measure with square miles? We've got to be measuring huge land masses, right? Well, we could. That's not. What's the square mileage of Pomona? How many square miles fit in Pomona? Well, if you can Google it, it comes out to 22.9 square miles. 22.9. In other words, let's see. I think I had a picture of Pomona. Did I? Pomona, where are you? There we are. Look at the city of Pomona. I have a map there. What would we measure with square miles? Well, the city of Pomona. Imagine a square. Look at the square I drew, where every side's 1 mile. That's a square mile. And imagine filling up Pomona with square miles. Okay? That would be an area question. Of course, my scores are all chwecked and garbage, but you get the idea. And just, by the way, just a little FYI, it's about 23 square miles. Pomona comprises 23 square miles of Southern California. Just so you know. By the way, has anybody been to the Phillips Mansion? Anybody been there? I heard it's pretty cool. It's like a nice mansion from way back at the turn of the century, like old school mansion by Phillips. But Phillips Ranch is named after that millionaire. All right, last one. We covered. Let's see. We've covered a parallelogram. We've covered a trapezoid. We've covered a triangle for a warm-up. The last shape I'm gonna cover right now is gonna be a circle, and we're done with our notes. Okay, so let's cover a circle now. The area of a circle. Okay. It's right here. Pi r squared. Pi r squared. So let me bring this down. We draw ourselves a circle. Okay, let's let's make the radius 20. There we go. All right. Go ahead and draw yourself a circle. This is example 4, our last example of the day. We're going to find the area and perimeter. Area but I'm not going to call the perimeter of a circle perimeter. The perimeter of other shapes are just the boundary, but this shape is not made up of straight lines. It's made up of pure curves, so we call the perimeter circumference. So I'm going to find area and circumference. When I put A, it means area. So there's a special name for the perimeter of a circle. It's called circumference. That's why you have these formulas right here for the C. There's 2 to choose from. They're both the same. You get to choose the one you would like to work with. It doesn't matter. Okay. Let's say this is 20 centimeters. Go to copy that down. Okay. Let's find the area then. Area is pi r squared. Pi is just a special number. It's always a ratio of the circumference to the diameter. Now when I say diameter, that's from one end of the circle to the other that goes through the center. For now, just know that pi is just a Greek letter from the Greek alphabet. Remember like sigma when we did standard deviation? These letters that we borrow from the Greek alphabet, the Greek is a very ancient language that a lot of scholarship and academics was done in. That's why we borrow these Greek letters. Greek was a very high language. Greek was used to write the Bible. The original New Testament and the Holy Scriptures was written in Greek. A lot of scholarship, philosophy, science was done in Greek. So we borrow these letters. Sigma, now pi. Pi is a Greek letter. And it's always, for our purposes, we're going to approximate pi to the hundredth place. It's going to be approximately 3.14. That's the ratio. How we get pi, put that to the side for now. That's another discussion. I'll go over that next week. But pi, for now, just know that we're always going to replace pi with 3.14. I'll get into reasons why later. Just know that pi is 3.14. So the formula is pi times the radius squared. Pi times the radius to the second power. Again, for now, just know that pi is going to be 3.14. I'll get into that Monday, why it's 3.14. The radius is always half the diameter. It's from the center to the outside. That's your radius. That's all we need is a radius in order to define the area. It's pretty easy. Well, look at 20 centimeters of the diameter. I know 20 centimeters is from here to here because 20 centimeters is right in the center. That's communicating that the whole diameter is 20 centimeters. So to get to the radius, just chop the diameter in half. It's going to be 10.
27.
Go ahead. Did I say 27?
Yeah.
My coffee hasn't kicked in. Shame on me. Let me drink some more coffee. I meant 20. Forgive me. So the whole diameter is 20 inches, or centimeters rather. We're going to chop that puppy in half to get to the radius. So in this case, obviously it's going to be 10. Here we go. Area then, watch this now. Pi is 3.14. The radius is 10 to the second power. We're rocking and rolling. This music goes good. Should I multiply first or do the exponent? Who remembers their junior high school math? Should I do the exponent or multiply first?
The exponent.
Thank you. Please excuse E stands for exponent. You do E before M. Please excuse my dear Aunt Sally. So we're going to do the exponent first. In other words, what's 10 to the second power? That means 10 times 10, not 10 times 2. In other words, 10 times itself. So area then, here we go, is 3.14 times 100. Because 10 times 10 is 100. coffee's good, but ineffective at this point. Here we go. Area then is 314. 314 chickens, horses, or termites. What are we counting here? Somebody says Ramos.
Square centimeters. Square centimeters. I mean, yeah. Centimeters squared.
Centimeters squared. In other words, imagine a bunch of square centimeters filling up this circle. I'm not going to spend all day here drawing them, but you get the idea. We're saying 314 would fill up the circle, the space inside, the two-dimensional space. Last mission, let's find the perimeter of the circle. But shame on me for calling the perimeter, it's not called a perimeter, it's called a circumference. And remember the stick figure guy from the video from Monday. The stick figure guy is going to walk around the circle, the boundary. We don't call that perimeter. There's a special name, like I said, it's called the circumference. How far would this dude walk if he walked all the way around the circle? Here we go. You have two formulas to choose from, ladies and gentlemen. Which one do you want to use? I can care less. You can do the circumference equals 2 times pi times the radius, or the circumference equals pi times the diameter. You choose the one you want. I can care less. I grew up with this one. The first one. So there's sentimental value. I'm going to use that one. But if you want to do the pi times the diameter, knock yourself out. Last one. Here we go. Circumference then is 2 times pi times the radius. Circumference then is going to be 2 times 3.14 times the radius is 10. Wow, this is easy. All the stuff from statistics that we've been doing, this is like child's play for you students. Here we go. 2 times 3.14, I want to say is 6.28 if my coffee is kicked in. And then 6.28 times 10 is going to be, watch this now, 62.8.
62.8, yeah.
What though? What units, Ramos?
Centimeters squared.
Cool.
No. That actually just centimeters because
Thank
it's
you.
just
Exactly. They were just one-dimensional. In other words, how many centimeters would this dude walk? He would walk 62.4 normal centimeters. 62.8 rather, just centimeters. One-dimensional, just distance, as opposed to area, which is two-dimensional. That's the square units that fill up the circle. I'm done. Go ahead and practice on C46. I'm going to post the answers to C46 in a little while. This way we're prepared for the quiz. I'm going to give you the quiz code in about 20 minutes. If you want to start the quiz now, I'm going to leave it on even after class ends. That's fine. Or come back today at 12:30 to finish the quiz off. Okay, but I want it done today, the quiz. So go ahead and practice right now on C46. Open up that PDF file. There's 8 problems to do. You only have to do 2 problems correctly if you want to get a 1 at least, just to move on to the next assignment. But you'll probably be ill-prepared for the quiz, but it's up to you. It's study time now. It's study time by doing the problems on C46. So get busy.